I'm going to find the Laplace transform of f of t, which is equals to 6 exponent of minus 5t plus 3 exponent of 3t plus 5t cubed minus 9. So we are given that function there. For the Laplace transform, we denote it by f of s, that is equals to the Laplace transform of f of t, and that will be the Laplace transform of 6 exponent of minus 5t plus exponent of 3t plus 5t cubed minus 9. Then we go on and use properties of Laplace transform to rewrite this expression here. The linearity property and that one for multiplying by a constant, so that our Laplace transform there becomes the Laplace transform of 6 exponent of minus 5t plus the Laplace transform of exponent of 3t plus the Laplace transform of 5 times t cubed minus the Laplace transform of 9. Here, where we have constants, we can take them outside there by the properties of Laplace transforms. So we have 6 multiplied by the Laplace transform of exponent of minus 5t plus the Laplace transform of exponent of 3t plus 5 times the Laplace transform of t cubed minus 9 times the Laplace transform of t to the power 0. Here we are having t to the power 0 just because when a factor, we remain with a 1, of which a 1, we can write it as a function of t, thus t to the power 0, which will enable us to use the tables there. So this is our expression now. And then we go on and look at the table of Laplace transforms. So this is the table that we are having, and I'll start by looking at this part here, exponent of minus 5t. In the column where we have f of t there, we look for a function which is similar to the one that I've highlighted, and we see that it is of this form, exponent of at. And by comparison of the two highlighted functions, we see that our a there is equals to minus 5. So what we'll do there is we substitute a equals to minus 5 in this expression here, so that we have our Laplace transform is 1 over s minus minus 5. And that will simplify to 1 over s plus 5. So that is the Laplace transform of the highlighted function here. So I can write it there as 6 multiplied by 1 over s plus 5. And then I go on to the next expression, this one, exponent of 3t. Exponent of 3t, we look at the column of f of t, we see that it is the form of this one here, exponent of at. And by comparison of the highlighted expressions, we see that a is equals to a 3. Then in the column of f of s, we substitute our a, we are substituting it here, so that we have our Laplace transform there is 1 divided by s minus 3. So I will substitute it for the position here, and would have plus 1 divided by s minus 3. And then go on to the next expression, which is this one here, t cubed. I'll look for a function which is similar to this one in the f of t, the column there. We will see that it is of this form, t to the power n. And by comparison of the two highlighted functions, we see that our n there is equals to 3. So if n is equals to 3, in the column of f of s, we substitute n equals to 3 here, and what we would have there is our Laplace transform is 3 factorial over s to the power 3 plus 1. 3 factorial is 3 times 2 times 1, which gives us a 6. So our Laplace transform becomes 6 divided by s to the power 4. So I'll go on and substitute it on this part here, so that we have plus 5 multiplied by 6 divided by s to the power 4. Then go on and look at the last one here, where we are having t to the power 0. T to the power 0 is of this form here, t to the power n. And by comparison of the two highlighted functions, we see that our n there is equals to 0. So if n equals to 0, we substitute it on this part here, so that our Laplace transform becomes 0 factorial over s to the power 0 plus 1, and that will give us 1 over s. So I'll go on and substitute it here, so that we have minus 9 times 1 over s. So that's the expression that we have there. We can just go on and multiply the numerators by these constants, so that our expression becomes 6 divided by s plus 5 plus 1 divided by s minus 3 plus 30 divided by s to the power 4 minus 9 divided by s. So that's the Laplace transform of the given f of t that we had.